Welcome students to chemistry class, and in this session we will talk about chemical thermodynamics. In previous session we have talked about different systems, thermodynamic systems, isolated system, closed system, open system, and in this session we will be talking about discussing about processes, types of processes, and how we calculate pressure, volume, and work, how we correlate them. So pressure, work and energy, all you know is thermodynamics is flow of energy. So we have to talk about how energy is flowing, and for that we should know that energy is required to do some work. So if work and energy are there, so there is some kind of thermodynamics is involved. So before going into types of processes, flow of energy, that is, so we should understand that what is thermodynamic equilibrium. So if there is equilibrium, there will be no flow of energy. So the first condition for flow of energy is a non-equilibrium. So let us understand and define what is thermodynamic equilibrium and what is thermodynamic non-equilibrium. So let us define that. Thermodynamic equilibrium is when a system is said to be in state of thermodynamic equilibrium when all the state variables remain constant throughout the system. So what are state variables? We have earlier discussed about that. So temperature is one of them. So just opposite to thermodynamic equilibrium is non-equilibrium. If there is some different values in different parts of the system for state variables, so the system will not be in equilibrium. So it will be in, the system is going to be in non-equilibrium. So for a thermodynamic non-equilibrium, all the different parts of the system will not have same state variable. They will have different, either one also, all of them, either one or few of them, or these state variables, if even one state variable is different, then we will say that the thermodynamic system is in a state of non-equilibrium. So we have, as we have discussed about thermodynamic equilibrium, so there can be different kinds of thermodynamic equilibriums. So one of them is, we have to understand and define also, these three equilibriums are very important according to our present aspect, this syllabus. So thermal equilibrium. So when we will say that some system is in thermal equilibrium, so when the temperature is uniform throughout the system, then we will say that the whole system is under thermal equilibrium. So here temperature is given the significant importance. So thermodynamic equilibrium is said to have constant temperature throughout the system. And another kind of equilibrium is mechanical equilibrium. So what is that? A system is said to be in mechanical equilibrium when no mechanical work is done by one part of the system on any other part of the system. So suppose I have a motor bike. So all of you know that motorbike has a engine, internal combustion engine. So when we put off that engine, what happens? The piston is at rest. No ignition, no expansion of gases, so no movement of the piston, and therefore no work. So at when the motorbike is off, then it is under the motor of that bike is under set to be under mechanical equilibrium. Once we start that, what happens? Ignition is put on, and then thereby what happens? The gases, the petrol or diesel, whatever is the fuel, is combusted, and it turns into vapors, and it pushes the piston, and therefore work is done. So mechanical work is done. So we will say that that engine is a system, and that system is not in mechanical equilibrium. So another type of equilibrium we can talk is chemical equilibrium. So what is chemical equilibrium? It is when we will say that throughout the system, throughout our chemical reaction or chemical composition, the composition of the system is uniform, it is not changing, then we will say that it is in chemical equilibrium. Like for example, you just consider a glass of water, transparent glass, and you have poured some water into that, and suppose you have dropped a colored ink into that. So what will happen? You will see that slowly that color diffuses from the top to the bottom, and finally eventually to the all parts of the glass. So what happened? The moment you have put a drop of colored ink, so chemical composition of water has changed, and that drop of ink was there at the surface, and now slowly but gradually it is diffusing, it is moved, the molecules of that ink move to the all parts of the glass, and slowly they are moving. So now you will say that your glass of water is a chemical system, and that is not under chemical equilibrium. Before adding that drop of ink, it was under chemical equilibrium. Why? Because throughout the glass only and only molecules of water were there and nothing else. So chemical composition was same. So we have talked about different kinds of systems, isolated system, closed system, etc., and types of equilibriums. Now we will talk how energy flows. So energy flows through various kinds of thermodynamic processes. So these processes are very, very important, and you should remember them. What kind of processes, what functionality is taken into care, and you have to consider that. So first of all, before understanding those processes, let us understand what is a thermodynamic process. So any operation which brings about changes in the state of a system is called a thermodynamic process. So any operation, suppose you have a glass of water, and in summers you want that you should drink some cold water to quench your thirst. So what you do, you add some pieces of ice cubes to that water. So what you have done, this is an operation. You have changed, you want to change the state of the system. You want to change the temperature of the glass of water. So your thermodynamic system is the glass of water, and now you are changing the state. So what you are changing? You are changing the temperature. You are changing the state of ice into water. So this is a thermodynamic process. So any operation, an operation that brings out changes in the state of a system is called a thermodynamic process. So there are different kinds of thermodynamic processes. Let us understand them. So one of the very important thermodynamic processes is isothermal process. So the moment you see the term iso, the prefix iso means same. So isothermal, so means thermal is for temperature and iso for same, that means same temperature. So the process occurring at same temperature, that is constant temperature, so that kind of process will be known as isothermal process. So for example, you have kept hot water in a thermos flask. So what is going on? There is no change of temperature. Why? Because thermos flask puts off puts a barrier to the water, that hot water kept in the flask, from its surrounding. So there is no change of heat, no exchange of heat. So that's why that water remains at its temperature at what you have kept it inside. So it is an example for isothermal process. Now another important process is isobaric process. So what is isobaric? Iso means same and bar means pressure. Baric means pressure. So isobaric pressure. So same pressure. So some processes, they happen at same pressure, at constant pressure. So there is no change in pressure. So delta, whenever you see delta, so that means change. Delta stands for change. So delta T is 0, means at constant temperature. Delta P is equal to 0, that means at constant pressure. So you can see various processes happen at constant pressure, like when you boil water, when you heat water in a tumbler, what happens? The atmospheric pressure is constant. There is no change in atmospheric pressure. So because you are heating, the water is boiling, it is the heating of water to boil it or to make it warm, to make it hot, is a simple example of isobaric process. You simply put mothballs in your cupboards and clothes to protect them from insects. What happens there? That mothball turns into vapors. So at what pressure? At constant atmospheric pressure. It is converting from solid to gaseous state. It is subliming. So this process, this change of state, there is change of state of the system and at constant pressure. So this change will be called as isobaric process. For example, camphor. If you put a piece of camphor at room temperature, after some time you will see that the quantity of camphor has decreased. So what happened? So you know that at normal temperatures, room temperatures, camphor vaporizes from solid to gaseous state. So this is called conversion from solid state to into direct gaseous state is known as sublimation. So this is happening, change of state is happening, but at what pressure? At constant pressure. That pressure is atmospheric pressure. So it is, you will say that this conversion from solid state to gaseous state is isobaric process. So another important, very important process is isochoric process. So isochore means, iso means same and choric is for volume. So at constant volume, the process occurring at constant volume will be known as isochoric process. So here change in volume will be 0. So very common, very day to day example is heating water or something in closed pressure cooker. So there is no change in volume. You have kept into a fixed volume. You are raising its temperature. So that is change. So heating water, you put water into pressure cooker, so it will boil. So this, because you have fixed the volume, so it is isochoric process. Now another very important process is, fourth type is adiabatic process. So adiabatic means there is no change, no exchange of heat between system and surroundings. No change. So that is at constant heat energy. There is no change in heat energy. So adiabatic process, there is no exchange of heat between system and surrounding. So you have to remember that. So adiabat, very important, a peculiar, uh, very peculiar about adiabatic changes is, generally or usually, not all but usually, adiabatic changes are accompanied by temperature changes. So for example, you have seen that sometimes while driving a car or some vehicle or even cycle during summers, what happens? The tire bursts. So because the tire bursts, what happens actually? It happens suddenly. So there, the tire the gas filled inside the tire or air is released suddenly through some aperture. So that gas or air is system, and there is no, it, because it happens suddenly, there is no exchange of heat from surroundings, so it comes out. So this is an example of adiabatic change. So even when your refrigerator, you put off your refrigerator, so what happens? Because motor is off, so what happens? Your refrigerator is insulated, thermally insulated from all the four sides and even from the top and bottom, so that whatever you have kept inside the refrigerator, it remains colder for a longer time. So what is happening? There is no exchange of heat from outside to inside. So this is an adiabatic process when your refrigerator is off. Okay, but when the refrigerator is on, actually its compressor is working to put out heat, it it is taking away heat from inside to outside. So at that time you cannot say that it is adiabatic process. But yes, when it is off, then motor is not working, then that your fridge itself works as a adiabatic process. And another very important class of process is cyclic process. And cyclic processes are very, very important. And what are actually cyclic processes? So, in cyclic processes, initial and final states of the system are the same, but they have undergone through various changes, but from initial state, but finally they have come to the original initial state. So these kind of processes are known as cyclic processes. So in cyclic processes, delta H is equal to 0 and delta E is equal to 0. Now you will ask question, what is delta H and what is delta E? These are new terms for you. So delta H is called enthalpy. H stands for enthalpy. So what is enthalpy? We will discuss about that in very detail, but for the time being you should understand that enthalpy is heat content of a system at constant pressure, is enthalpy. And what is E? E stands for internal energy. So any system at a particular point of time has some energy. Maybe it may be very, very high, it may be very, very low, but it may not have any energy. But we it is that energy that is stored in that system at a particular point of time is its internal energy. So we will talk about these two terms in greater details later, but for cyclic processes there is no change in its enthalpy, there is no change in its internal energy. So these two are constant. So this is characteristic about cyclic processes. So cyclic processes is like same, you have started from your home, so it is your initial state, you have reached to your market, so that is another state. Now after doing some shopping and other day to day work, you have returned from there and reached home. So what happened if I consider your whole roundabout? So you have, the moment you have started from your home, you have changed your state, you have reached some shop, it is another state, and after doing so many rounds of work somewhere, and you have ultimately in the evening you have reached to your home. So your final state is your home, destination is your home. So although you have traveled a lot, done various things, you are at the same place. So this is kind of cyclic process. So your initial position is same and final position is also same, there is no change. So this is in this way you can understand about cyclic processes. So in cyclic processes there is no change in internal energy, there is no change in enthalpy. Now there are all we very important class of processes, we can categorize them reversible and irreversible processes. So what are reversible processes? Something like you have taken water, cooled it, it becomes ice. If you take out ice, melt it, it will become water. So this is reversible change. Okay, but you take a piece of paper, burn it, now it has turned into carbon black, powder, ash. If you want to cool it and generate the same piece of paper, can you do that? It is not possible. So it is irreversible process. So thermodynamic processes are also categorized irreversible and reversible processes. So what is characteristics of reversible process? So reversible process is a process which is carried out very slowly, infinitesimally slowly. Infinitesimally slowly means very, very, very slow, short and slow, in such a way that each step remains in equilibrium with its previous step. Like, suppose you are trying to walk, so you have to go from your home to 10 kilometers away some destination. But what can happen the moment you take first step, and you after you have taken your first step, if you there is possibility that you can come back to your original position. So you have you can come to equilibrium with your previous step. This So each step is in equilibrium with the previous step. So, and this process could be reversed. So if you want to come back from your door to your room, it is easier. But when you have reached 10 kilometers away, if you want to come back, it is not that easy. So but you can reverse yourself by just going out and coming back. So so each step should be very infinitesimally small, and the previous step and the step you have taken should be in equilibrium. You can reverse it at any stage. So such processes are known as reversible processes, and when this condition is not fulfilled, then that process will be known as irreversible process. Now we have discussed about processes, systems and equilibrium. Now actually how thermodynamics takes place, how flow of energy happens. For that there are two things. Thermodynamics deals with energy, particularly heat. So heat is required here, and when you heat something, so like locomotive engine, so what do, you heat the water in the boiler, and from you extract work. So heat is converted into work. So this transformation, so heat and work are very important entities, so we have to deal with that. So let us understand heat and work. What is heat? Although you have studied in physics, so we will just go through that. Heat is a form of energy exchanged between a system and surrounding when the two are at different temperatures. So this is commonly known as heat, and the unit of heat is calories, joules. SI unit of heat is joules. And work is the term usually referred for mechanical work. Here we will talk for mechanical work which is said to have been done if the point of application of a force displaces in the direction of the force. So work can be defined as force multiplied by displacement in the direction of the force. So what is the unit of work? The unit of work is also joules, ergs. SI unit is joules. So you have to remember that. Although we have discussed about the sign conventions about work and energy, but still we have to I would like you to refresh it. So when the system gains energy, so we will assign it a positive sign. When the system loses some energy, we will assign negative sign to the system. Similarly for the work also. If work is done on the system, so indirectly actually what is happening? Some energy is being given to the system. So therefore we have to put a positive sign. We have to assign positive sign. And when work is done by the system, so what happens? When the system does some work, it loses some energy. So because system is giving out some energy, so we have to assign a negative sign. So these are the sign conventions you have to always keep in mind, and they are very very important, so please remember that. So we have discussed about energy and work. So there are different kinds of work we can take out from energy. So what are, we will discuss few kinds of work, like mechanical work. We have already discussed that work is applied force into displacement, and electrical work also. So what is electrical work? It is defined as product of EMF and quantity of electricity. What is EMF? It is electromotive force. So it, how this work is done? This type of work is actually by reaction between ions. So it involves ions, chemical ions. So they transfer charge, and that movement of charge, movement of electron is known as electricity. So the how much quantity of electricity and what is the electromotive force, that product will give you the electrical work. And pressure volume work, it is very very important, and we will discuss this in detail. So you have to learn and give more importance to this pressure volume work. So this is a kind of mechanical work, and it actually takes place when the system and surroundings are at different pressures. So although we have already studied in gaseous state that you, when you apply pressure to some gas, what will happen? There is change in volume, etc. So pressure causes some change, pressure does some work. So that work can be calculated by this relation. Work is equal to pressure multiplied by change in volume. We will find out how this equation is coming. So these are three kinds of work, and we have to mainly focus on pressure volume work. So let us consider pressure volume work and how to calculate the work done by pressure volume change. So for that we have to take a very simple experimental setup where we have a cylindrical cylinder that is having a movable piston and frictionless. So all the pressure that we are applying is only utilized for movement of the piston. No energy is being lost or gained. So this is our assumption. Now, so because we are applying pressure from outwards, so the pressure we are applying here is external pressure, and initial volume of the cylinder, where the initially the piston was positioned, is V1. So let us say that volume be V1. Okay, and because certain amount of gas is present inside the cylinder, so let that quantity of gas exert a pressure P on the piston and the walls of the cylinder. So let us assume that the pressure exerted by the gas inside enclosed is P, and because you all know that gas occupies all the volume that is available to it, so let that volume be V at initial position of piston. So that is V1. We have assigned that as V1. Initial volume of the gas is V1. So if we apply force from outwards and move the piston inwards, so definitely we will compress the gas. We will compress the gas, and because we are moving the piston inside, so there we are doing some work, because what is work? Work is force into distance, and we are applying a force, so there is a force F. Let that force be F, and because the piston is moving, so let the piston move a small distance d, so that is a distance d. So work can be calculated. Work is equal to force into distance. And how to know that how much amount of work has been done? So for that we know that area of the piston, so we can simply calculate, because here our piston is spherical, so pi r square, area can be calculated, and the distance it has moved d, so area into distance gives volume. So and pressure can be written, force can be written as pressure into area. So our equation becomes P into A into D. So P is our pressure, and A multiplied by D is, as we have discussed, is change in volume. So P delta V. So now let us derive. So let us do that derivation for pressure volume work. So we have already considered a gas is enclosed in a cylinder fitted with a movable piston, and volume of the gas enclosed in the cylinder is V, area of cross section of the piston is A, external pressure that is exerted on the piston is denoted by capital P, and the small distance moved by the piston is dl. Okay, so the change in volume, because the change in volume is very small, so we will say that dV, and it is given by dV is equal to area into distance moved by the piston, so A into dl, and the force acting on the piston is F, and that is equal to pressure into area. So if the work done by small movement of the piston is denoted by dW, so how we are going to calculate that work? So we already know that work is equal to pressure into change in volume. So dW is equal to pressure into change in volume, and we have applied pressure P, so there is, we will write capital P, and we have given a minus sign, we have assigned minus sign, and why this minus sign is there we will discuss in details when we will talk about the first law of thermodynamics. So let us be it there. So minus P multiplied by change in volume. So what is change in volume? Because the piston's area of cross section cannot change, so it is A, and because it has moved a small distance dl, so A into dl is small change in volume, so minus P into dV. So if the piston, the pressure is constant, we are not varying, then the total work done can be given by W, and W can be given by small letter w, and this is equal to, we can integrate this equation, the above equation. So on integrating from limit v2 to v1 p dv, so integral shows that minus p, and because v2 to v1, so upper limit is v2, lower limit is v1, so v2 minus v1. And what is v2 and what is v1? v2 is the final volume and v1 is the initial volume. We have already considered, so we can write this equation on integrating, w is equal to minus p delta v. So the change in volume, I have already told you, whenever we want to denote change, we write delta, delta v, delta t, delta p. So change in volume, change in temperature, change in temperature, pressure, etc. So for that we write delta v, delta t, delta. So here w, work done, is equal to minus p delta v. So this is the general expression for pressure volume work, and this derivation is very important. You may get as a question in your examinations, so please learn this derivation thoroughly. So I have already explained what is delta v. Delta v is change in volume, that is given by final volume minus initial volume. So when we consider a gas enclosed in a system, closed cylinder, there can be two cases. Either gas can expand, and either we can contract the gas, as we have discussed in our example. We have considered for that. So it was a case of contraction of gas. Okay, now we were compressing the gas. So let us consider these two cases on the basis of the general expression we have derived. Work done is minus p delta v. So let us consider the case of expansion of gas. So if the gas enclosed in the cylinder undergoes expansion, then what will happen? Initial volume will be always lesser than the final volume, because gas is expanding. So its initial volume will be lesser, final volume will be greater. So delta v, what will happen to delta v? That is change in volume. v2 minus v1, that is final volume minus initial volume, will always be positive, because suppose if a gas is expanding from 2 liters to 4 liters, so what will happen? It change in volume, it is plus 2, 4 minus 2, it will be positive sign, bear a positive sign. So what will happen to work done? Work done will always be in negative. So work done in expansion of gases is negative. Why this is negative? It has a significance, because the gas is, when the gas is expanding, it is doing work on the surroundings, and because it is doing work on the surroundings, so it is losing some energy, and because it is losing some energy, we are assigning a negative sign. And now let us consider the second case, that is contraction of gases or compression of gases. So what will happen here? When a gas is undergoing compression, so what will happen? Its final volume will be always lesser than the initial volume. So change in volume will be what? Suppose if a gas is having 5, its initial volume was 5 liters, and we have compressed it to 2 liters. So the change in volume is final minus initial. So final is 2 and initial was 5. So it is minus 3 liters difference change. So volume change will be negative, And what will happen, because our equation says that work done is equal to minus P delta V, because minus P is there and delta V is negative, so on multiplying it becomes positive. So work done in contraction of gases is always positive. So what its implication, what is its implication? So it means that surroundings are working on the system, so they are putting energy into the system, so increase in energy. So that's why it is positive, it bears positive sign when gas is contracting. So work done is positive. So now let us do one numerical based on the above equation. We have derived and we have talked about its two cases, case of contraction and expansion. So a cylinder of 2 liter capacity contains argon gas at 25 degrees centigrade with a movable piston. What will be the work done if a pressure of 15 atmosphere is applied to compress the gas to a volume of 0.5 liters, and consider that pressure is constant, that the pressure we are applying is 15 atmosphere, there is no variation while applying. So what information we have been given? We have been given that the initial volume of the gas was 2 liters at 25 degrees centigrade. So there is no change in temperature at the same temperature, so you don't have to worry about the temperature, so leave that temperature. Okay, so initial volume we know it is 0.5 liters, 2 liters, sorry. And finally, because we are applying pressure to the gas, so its final volume is 0.5 liters. So what is the change in volume? Change in volume is final volume minus initial volume. So 0.5 liters minus 2 liters, so that gives minus 1.5 liters. That is the change in volume, minus 1.5 liters. So because we have already learnt that work done is equal to minus P delta V, and P pressure is given here is 15 atmosphere. So let us put these two values. We know that the pressure, we know that change in volume, so we have to simply put the values. So minus sign, and pressure is 15, so minus 15 atmosphere multiplied by minus 1.5 liters, that is change in volume, and on multiplying minus minus becomes plus, and 15 into 1.5 gives you 22.5, so the value comes out to be 22.5 liters atmosphere. So this is the work done. So if I want to convert this work from liter atmosphere to joules, so I have to multiply with a factor of 101.325. Why? Because 1 liter atmosphere is equal to 101.325 joules. So on multiplying with that factor, we get 2279.8125 joules. So work done here is positive because it is contraction, a case of contraction. We have already learned that while contraction, work done is positive. So positive, and the numerical value is this much joules. So in this way you have to solve the simple questions. So you have to assign the sign, whether it is negative or positive. That is very important, and that bears some marks there also. So if you don't put sign, so you will may not get some marks. Some marks may be deducted. So you have to be very particular about sign and the numerical value and your units. So all while writing your final answer, you have to write the sign it is positive or negative, then the numerical value, correct numerical value, and then joule, the unit. So if you write the three things correctly, you will get full marks for that. Otherwise, some marks may be deducted. Thank you.